Now let's look at one more methodology or one more approach to mitigate the multicollinearity problem. So in the previous example, we did not directly deal with multicollinearity. We simply looked at the errors being autocorrelated, and we tried to extract the autocorrelated part of the errors into our forecasting process. But one way of mitigating multicollinearity is, instead of looking at the original values of y that are correlated among each other, okay, if we take the difference going from one time period to the next time period, one time period to the next time period, if you look at the difference in the values of the variables, okay, that will in many cases get rid of the multicollinearity problem. So instead of using the original values, we take the difference values, and then we start building the models like what we have done previously. Okay, so let's go back to the same example. Now, instead of using the original values, we take the differences and then go through the process of VIF and forward selection, backward elimination, etc., etc. So here, the same problem like before. Okay, so we have the data, unleaded price, that's our response variable. We want to forecast that, and then we have crude and employment and so on and on. So we want to look at the lagged values as the starting point. So let's set up the lags first. So we're going to use X sub 1 as the notation for L1 unleaded, X sub 2 for L1 crude, and so on. So the first variable here would be like that minus that. So that will give us the L. Now L1 unleaded is just simply that. Okay, we are lagging by one time period. Okay, now if we copy that rest of the way, so that will lag everything by 1, and then okay, the time should be not lagged, so that will be, time will be just that. Okay, so now we copy this, okay. Alright, so now we have that data set up. Now what we want are the differences for y through x sub 7. Okay, so we'll put the prefix d to indicate we are looking at the difference in those variables. So the very first one is going to be y sub t minus y sub t minus 1, the previous value. Now similarly, d of x sub 1 is going to be L1 unleaded of a given time period minus L1 unleaded of the previous time period. Okay, and similarly the rest of the variables. Okay, so each of them would be a given value minus the previous value. Now when we do this analysis, time need not be considered, because if you take the time, this current value minus the previous value, then the difference is going to be 1 all the way. It's not going to change at all. So there is no d of x sub 8, so because it will be a constant value. Okay, so let's set that up here. Okay, so the very first difference is now going to be, we've already lagged by 1, so the very first difference is going to be for, okay, so here are the d variables, d for y and d for x sub 1 through x sub 7. And you notice that since we're going to be taking differences, we've already lagged by 1, so the very first difference we can find is for row 26, in other words the third time period. So that's why we have to leave the first two blank, and I'm setting up the labels here, so when we run regression we'll be able to use those labels. So the very first difference here for y is going to be, go to the unleaded, period 3 minus period 2. So similarly for dx sub 1 is going to be that minus the previous one. Okay, so now we can copy this across like that. So make sure that dx sub 7 is that minus that, so there is no difference for time. Okay, so now we copy this for the entire sample. Okay, so we'll use the estimation sample for the purpose of estimation, and then we will look at the holdout sample for the purpose of measuring the forecast accuracy. So that's where the separation is between estimation sample and holdout sample. Okay, so now the first step is to run a correlation and then compute the VIF values and then see whether we can eliminate some of these variables from consideration. So we'll do that in the next video.